Usually when we talk about a medical diagnosis, there's this underlying expectation of precision, right? Like, it feels almost like engineering. You break your arm, the x-ray shows that jagged white line, and the doctor just points and says, there it is.
Yeah, exactly. It's a binary state. Like, it's broken or it's not broken.
Hmm.
And it's clean, visible. And, I mean, honestly, it's incredibly comforting because it's so easily categorized.
Right, but step into the world of evaluating artificial intelligence, and suddenly that x-ray machine is just, well, it's completely useless. We're looking at a diagnostic landscape that is entirely murky, especially when you are trying to figure out if an AI is actually doing what you asked it to do in a really complex, messy business environment.
Oh, absolutely. The business environment is where things get really wild.
Yeah, and today we are doing a deep dive into some new research that proves something pretty terrifying for anyone using enterprise AI. Like, if your AI gets the right answer, it might actually be getting stupider.
Which, I mean, that completely upends the way most of the tech industry operates right now. This research, it comes from a joint team at HKUS, GZ, and Shady.com. It's a fascinating new paper titled SkillCoach, Self-Evolving Rubrics for Evaluating and Enhancing Agentic Skill Use. And it targets this massive blind spot we have.
Because the assumption has always been that a successful outcome equals a smart AI, right? Like,
Yeah.
if you deploy an AI right now, you probably have this nice little dashboard showing how many tasks it completed successfully.
Exactly. And this paper shows why that dashboard is, well, it's likely lying to you.
Okay, let's unpack this because that's a huge claim. We're basically talking about why process over outcome is the mandatory future of reliable AI.
Right, so think about what we call the final verifier, which is, the industry standard metric right now.
Mhm.
Did the AI write the code that compiled? Or did it generate the Q4 financial report without crashing the entire server?
Right, did it get the job done?
Exactly. And if the final verifier says yes, we give the model a pat on the back, we log it as a success, and we just move on. But in a real enterprise setting, an AI agent doesn't just magically produce an answer. It relies on a vast library of what we call skills.
And just to clarify for everyone listening, when we say skills in this context, we aren't talking about like human talents like public speaking or whatever.
Yeah.
We're talking about software tools, right? Like reusable procedures, APIs, Python scripts, database queries.
Yeah, exactly. Those kinds of standard operating procedures. So the fundamental problem identified by the researchers is this. When an AI succeeds at a task, it might have perfectly executed the correct gold skill, the exact workflow you actually want it to use.
The ideal path.
Right. But alternatively, it might have just stumbled through this maze of trial and error, picked completely wrong distractor skills, skipped 3 mandatory security checks, and just frankly gotten lucky at the very end.
It's like grading a middle school math test. If you are a teacher and you only look at the final answer circled at the bottom of the page, you give an A+ to the student who diligently followed the algebraic formula step by step.
Yep.
But you also give an A+ to the student who just made a lucky guess or, maybe just peeked at their neighbor's paper.
That's a perfect analogy. Take those test scores and try to decide who gets into an advanced engineering program. You instantly have a massive systemic problem. If we only train and evaluate our AI models based on, did it pass the final check, we are inadvertently rewarding and reinforcing these brittle, chaotic, totally non-reusable behaviors.
Wait, but I can hear people asking right now, like, in the real world, businesses only care about the bottom line. If the AI puts a perfect Q4 financial report on my desk and the numbers are completely accurate, why on earth should I care if it guessed or stumbled to get there? Like, the outcome is what I pay for, right?
You care because a lucky guess doesn't scale. And it is wildly unpredictable when conditions change, even a fraction of a percent. I mean, the paper provides this compelling data on the sheer cost of this trial and error approach. An AI that guesses wastes massive amounts of compute power just pulling up the wrong tools and hitting dead ends.
Oh, right, because API calls and compute time cost actual money.
Exactly. It slows down the entire pipeline. But more importantly, think about compliance. If your AI stumbles into the right answer today by skipping a mandatory data privacy check, but the final verifier only looked at the output format and didn't catch the skip step, what happens tomorrow?
Tomorrow, that exact same missing check results in a catastrophic data breach.
Exactly. You need the underlying process to be rock solid. The final output is just, well, it should just be a byproduct of a good process.
So a lucky guess is basically a ticking time bomb. If the final outcome is an unreliable metric, if the final answer on the math test is lying to us, how do we actually look inside the black box and measure the AI's internal process? Like, how do we grade the scratch pad?
So the researchers needed a way to measure this metability of the AI to use tools. So they define agentic skill use not as a final result, but as a trajectory across 4 very specific dimensions. They break the process down into measurable steps.
Okay, what's the first one?
The first dimension is skill selection. Did the agent pick the right gold skill and actively avoid the distractors? Crucially, this includes something they call negative abstention.
Meaning, if there is no applicable tool for the prompt, does the AI know when to just stop and say, I can't do this? Like, not every problem needs a hammer.
Precisely. The AI has to recognize the limits of its own toolkit. It can't just, hallucinate a tool that doesn't exist. So that's the first one. The second dimension is skill following. Did the agent actually perform the key steps outlined in the standard operating procedure?
So it's not enough to just say it's doing it.
Right. It is not enough to just print the name of the API in its internal monologue. It has to execute the specific parameter requirements in reality.
It can't just say, I'm going to check the database. It actually has to write and execute the SQL query.
Yes, exactly. Then the third dimension is skill composition. This applies when a task requires multiple skills to interact. Did the AI use them in the correct sequential order, and did it pass the intermediate data from one tool to the next correctly?
Oh, I see. So if tool A outputs data in XML and tool B only accepts JSON, did the AI recognize that and perform the conversion?
Exactly. Or did it pull the raw data first before trying to format the final chart? It's really the connective tissue between the tools.
Got it. And the fourth one?
The fourth dimension is skill-grounded reflection. Did the AI perform explicit, visible self-checks before its final submission? Did it actively validate the output files or compare the schemas against the task constraints before declaring the job done?
Here's where it gets really interesting, because when I was reading through the source material, there was this one specific detail in the appendix about how they actually grade this reflection.
Oh, the evaluator prompts.
Yeah. The researchers provided the exact system prompts they use for the evaluator system. They strictly tell the evaluator, do not infer hidden reasoning. Only visible trajectory evidence counts. It is so rigid, but it makes perfect sense. Like, you literally cannot give the AI the benefit of the doubt. If the AI didn't explicitly write down that it checked its work, it didn't check its work.
What's fascinating here is that mirrors strict human compliance auditing perfectly. An auditor from a regulatory body doesn't care if a factory worker, thought about checking the safety pressure valve. They want to see the initial logbook with the timestamp.
Right. Prove it.
Exactly.
Yeah.
The researchers apply that exact same unforgiving rigor to the AI's digital trajectory. No evidence, no credit.
So we have these 4 dimensions: selection, following, composition, and reflection. Knowing what to look for is great in theory. But how do top-tier, frontier AI models actually perform on these dimensions when you throw them into a real corporate database? Because, most of those flashy AI tech demos show the model in this pristine, sterile environment where it only has access to exactly the 3 tools it needs for the demo to work.
Yeah, and that pristine environment is the exact illusion this paper dismantles. The researchers conducted a massive distractor boundary analysis. In a real company, an AI isn't just handed the perfect gold skill on a silver platter. It has to find it among thousands of other tools, deprecated scripts, and legacy workflows.
It's a mess.
It's a total mess.
Yeah.
So they stress-tested models like GPT-5.5, Opus 4.7, and Gemini 3.1 Pro by injecting up to 50,000 real distractor skills into the environment.
Wait, 50,000 extra tools. That is a monumental haystack to hide a needle in.
It's huge, and it reveals 2 distinct breakpoints for how AI models handle environmental noise. The first breakpoint is what they call the degradation boundary. This is the threshold where the AI's performance first starts slipping noticeably, or it starts picking the wrong tool occasionally, or getting bogged down.
Okay, so where does that start?
For Gemini 3.1 Pro, degradation started surprisingly early, at just around 45 to 46 distractors.
Wow. Only 45 extra tools and a massive model like Gemini starts getting confused. That feels incredibly fragile.
The precision really does drop fast. But the second breakpoint is the collapse boundary. This is where the model completely fails to find the right skill 80% of the time. It essentially gives up, loops infinitely, or totally hallucinates a response.
And when does that happen?
Well, the fascinating thing about Gemini 3.1 Pro is that while it degraded early, it didn't hit this total collapse boundary until around 35,000 distractors. So it takes a hit to its efficiency early on, but it hangs on for a very long time before totally breaking.
Interesting. What about the others?
DeepSeek V4 Flash, on the other hand, collapsed much earlier, at around 6,400 distractors.
I saw in the data that the sheer volume of distractors isn't even the deadliest part, right? It's the type of distractor. Like the paper mentions that adding totally random, unrelated skills doesn't confuse the AI much at all.
Right. If the AI needs to pull a financial report and you add a skill called translate to French, it ignores it immediately.
But if you add high similarity distractors, the performance absolutely tanks.
Oh, completely. If you add a distractor called PolQ3 Financial Summary, which has the same parameter requirements and looks almost identical to the PolQ4 Financial Summary Gold skill, that is where the models get completely paralyzed. They can't distinguish the nuance.
Wait, so even a massive cutting-edge AI like Quen 3.59b struggles here. I looked at this stat from the paper. Its skill selection score dropped from 92% all the way down to 44% just by adding a few of these high similarity distractors.
It's a dramatic drop.
It's literally like an employee searching the corporate intranet. Like, if there's only one expense form, they'll find it. If there are 50 obsolete versions of that form from the last decade, they're going to click the wrong one. The AI is doing the exact same thing with APIs.
And the scary part is a final outcome check doesn't catch that error until, accounting rejects the human's form 3 weeks later. For the AI, it might pull the wrong version of the API, try to force the parameters to fit, fail, try another outdated one, and eventually spit out something that looks structurally right but violates your company's current data protocols.
Okay, so if massive models like Gemini and Quen are failing just because we named a file similarly, manual debugging is out of the question. I mean, a human manager can't write a custom grading rule for 50,000 edge cases and high similarity distractors. It would take decades. How do we actually fix this evaluation bottleneck?
You're right. Manual rubrics absolutely don't scale. That is why the researchers built the core innovation of this paper, SkillCoach. SkillCoach is a framework that creates self-evolving rubrics.
Self-evolving? Wait, so the system writes its own grading rules. How does that actually work in practice without just spiraling out of control?
Well, it relies on a feedback loop based on observable evidence. It starts with an initial baseline rubric based on a general task description. Then it watches real AI agents attempt the task. It analyzes the visible execution logs, that trajectory we talked about earlier.
Okay, I'm following.
If SkillCoach sees an AI fail the task, but the current rubric scored that AI's process highly, the system realizes there is a gap in its own grading criteria. It recognizes it missed something crucial.
Let me see if I have this right. Let's say an AI pulls data successfully, but it doesn't close the SQL database connection, causing a memory leak.
Sure, classic issue.
The baseline rubric didn't explicitly check for connection closures, so it gives the AI a 90%. SkillCoach sees the memory leak in the final system state, traces it back, and says, oh, my rubric is flawed. So it drafts a local patch to add verify SQL connection closure to its own rules.
That is exactly the mechanism. It uses the delta between process scores and outcome failures to patch itself. But it doesn't just wildly append rules. The researchers implemented strict architectural controls. There is a hard gate, which evaluates every proposed patch and rejects any destructive changes.
Like what?
If the system proposes a lazy patch that says, let's just bypass the final verifier completely to make the scores match, the hard gate blocks it instantly.
Oh, good. So it can't game the system or cheat its own test?
Exactly.
Yeah.
And alongside the hard gate, there is a soft objective that encourages the rubric to improve its evidence coverage over time. It constantly pushes the rubric to look for more specific, concrete, visible steps in the execution logs rather than vague summaries.
This is incredibly meta. I mean, we're using AI to automatically write, test, and refine the grading rubric that is then used to grade other AIs.
It's a completely automated quality assurance loop. And the empirical results from running this self-evolving system are just stunning. By allowing SkillCoach to evolve its own rubric, the hallucination rate, which is when an AI evaluator invents fake constraints that aren't actually part of the original task, dropped from 2.0 to a perfect 0.0.
Wait, really? It totally eliminated fake rules? It stopped making things up?
Entirely. Zero hallucinations. Even more impressively, its trajectory filtering consistency with expert human judges increased from 82% to 96%.
That's massive.
Yeah. SkillCoach essentially became a near-perfect mirror of a meticulous human auditor, but operating at a scale and speed no human could ever match.
Okay, so having a perfect, self-evolving, unforgiving grading rubric is a massive win for evaluating an AI. It's great to have a harsh grader to catch errors, but does it actually help improve the AI's future behavior?
Right.
Like, can we use this flawlessly patched rubric to make the base models better, or does it just tell us how bad they currently are?
Oh, this is where the real payoff of the research happens. The researchers use these evolved rubrics for supervised fine-tuning, or SFT. They took a smaller model, the Quinn 3.54b, and decided to train it by feeding it massive amounts of past examples.
Okay, standard training process.
Right. But first, they tried training it the old-fashioned way. They only fed it training data from trajectories that passed the final outcome check. Regardless of how chaotic the AI's path was, if the final answer was right, they used it as a positive training example.
Feeding it a diet of lucky guesses and messy paths that just happened to cross the finish line. So what happened to the model's accuracy?
The model's accuracy actually dropped from an 8% success rate down to 6%.
Wait, so if we train an AI on its own lucky guesses, it actually gets stupider?
Yes, because it learns terrible habits. It reinforces the chaotic path. It learns to waste time, click random APIs, ignore safety procedures, and just churn until something works. It essentially optimizes for noise. But then, the researchers switched tactics. They filtered the training data using the strict SkillCoach process rubric. They only allowed the model to learn from instances where it explicitly showed its work, followed the key steps, and obeyed all 4 dimensions of process.
And the results?
When they trained it on that filtered data, the model's accuracy tripled. It jumped from 8% to 24%.
So if we force it to only learn from instances where it documented its work and followed the standard operating procedure step by step, it gets drastically smarter.
Exactly. And the researchers wanted to know which of those 4 dimensions was doing the heavy lifting for that massive improvement. So they started stripping them away one by one from the training data in an ablation study.
Oh, that's smart. What did they find?
They found that removing the requirement for key step following caused the largest drop in the trained model's performance. When they stopped forcing the AI to explicitly follow the steps, its performance plummeted from 24% back down to 10%. Yeah, following the actual standard operating procedure transparently is the most vital signal for long-term improvement.
So what does this all mean? If you're listening to this and you're deploying AI in your company right now, or even just building personal workflows, this paper is a massive wake-up call. Like, you need to stop cheering just because the AI gave you the right output at the end. You have to look at the process.
Absolutely.
Ask yourself, are you giving your AI a clear rubric? Are you actively checking its execution logs? Or are you just accepting the final text file and hoping for the best? Because if you are just accepting the output, you might be scaling a fragile system built entirely on lucky guesses.
This raises an important question to consider about the future of work itself. SkillCoach proves that highly complex, dynamic corporate environments require self-evolving rubrics to ensure process compliance, because static rulebooks fail when things get messy, when databases update, and when tools overlap.
Right. The environment is always changing.
Exactly. So if AI systems are now capable of automatically generating, refining, and strictly applying these flawless evidence-based process rubrics to evaluate the step-by-step actions of other AIs, how long until corporate HR departments start using these exact same self-evolving AI rubrics to evaluate the daily process compliance of their human employees?
Oh, wow. That is, yeah. So instead of a manager just looking at the final quarterly report I hand in, the AI rubric is auditing my daily trajectory, tracking exactly which internet files I clicked, what order I did the work in, and whether I explicitly checked my own math before hitting send.
It's entirely possible.
We wanted a better X-ray machine for the AI, and we might just end up putting ourselves under the lens. Something to think about next time you decide to skip a mandatory step in your own workflow. That's all for today's deep dive. We'll see you next time.